All right, this is Mr. Gillum, and today we're going to learn how to start graphing one variable inequalities. All right, so let's check it out here. Remember, an inequality is a symbol that determines whether a value is greater than, less than, greater than or equal to, or less than or equal to another value. So it could be a greater than sign, a less than sign, a less than or equal to, greater than or equal to. Those are all different types of inequalities. And an inequality takes the place of an equality. So um, if we know that x equals 3, there is one solution. Okay, we call that an equality because there's an equal sign, equality. And that's because that equal sign there. An inequality, would be like x is less than 3. And we're just going to say there are many solutions. Specifically, there are infinitely many solutions, because there's a lot of things that the variable x could be to make this true. In an equality, x has to equal 3. In an inequality, x could equal 2 is less than 3, or it could equal 1, or 0, or -1 even, and it gets smaller and smaller and smaller. So there's many solutions. There's many things that the variable x can be. And so instead of listing out all those infinitely many solutions, I mean, we're never going to run out of numbers that are less than 3. We could even do decimals. We could even do 2.9 is less than 3. 2.5 is less than 3. 2.99999, lots of nines, is always going to be less than 3, unless it's 9 repeating. We'll get to that on another day. But as you can see, there are a lot of different things that I could make the variable x to be less than 3. So for an inequality, and that would be greater than, less than, greater than or equal to, or less than or equal to any of these, there are many solutions whenever you see an inequality. Okay, I just gave one example, but whenever you see an inequality, you need to understand there's a lot of different solutions, a lot of things that x could be, or the unknown could be. And so in order to represent all of the different ways that we could have a true solution, what we actually do is we model on a number line. We graph on a number line. It says there's many solutions in an inequality. And a greater than or a less than symbol is modeled with an open dot. And so I'm going to say those words quite a bit, open. Okay, a less than or a greater than, we get open dots. And for a greater than or equal to, or less than or equal to, we have closed dots. And so I'm going to be very specific. I'm going to make sure I shade it in. And the reason we shade in with the equal sign underneath means it's okay to include that value. Okay, it's okay to be equal, so we're going to include it. We're going to actually color it in. On a greater than or less than, we can't include the value. It doesn't count. Like for instance, 3 is less than 3, that makes no sense. Okay, we can't include it, so we leave it as an open dot. So it comes really, really close, like 2.99999 is still less than 3, but never when you get all the way to 3 will it ever be true. Okay, so we leave it open. All right, so I know that the inequalities are not on your paper, but we're going to graph each of these inequalities. All right, and if you'd like to just write them off to the side for each number line so you know which one you're graphing, that'd be great. But I do believe you have 4 number lines, and in this instance I didn't actually graph or put numbers on the number line, so let's go ahead and we'll start at 0, and since this is 3, we'll go 1, 2, 3, 4, 5, and I'll just label the 3 there since that's the point of emphasis, and we'll just label this one as well, 0, 1, 2, 3, 4, 5, and I'll just label the 5 there, and that means that each one of these tick marks represents 1. 4, same idea, 1, 2, 3, 4, and 6. 0, and we'll go 2, 4, 6. I'm going to put a 6 there, and I know I only put 3 tick marks, but what that means is that the distance between each of the tick marks is actually 2 that time. And so as the numbers get bigger on maybe your homework, you'll use strategy and you'll kind of use appropriate increments for each of your tick marks to represent. Okay, so you're not, if you're graphing 100, you're not going to have 100 tick marks. You're going to maybe go by 10s or 20s or whatever you decide. But use the appropriate scale on your number line. On the other side of 0, of course, if this is 1, there would be -1. And if this is 2, there would be -2. And we kind of touched on this when we talked about absolute value, the distance from 0. There's two numbers that have a distance of 3 from 0. It's 3 and -3. So I'm just going to label a few negative ones too. There's -5. 1, 2, 3, 4. We'll call him -4. 2, 4, 6. There's -6. Okay. And so it's just good to have a good perspective on our number line, because after all, some of our solutions included might be negative numbers. And so that's what I'm going to look at first, is this first inequality, x is less than 3. Now, when I think about x is less than 3, I think there's a lot of numbers that it could be, okay? It could be 2 or 1 or 0 or -1 or -2 or -3. All those numbers are on the smaller side of 3. And we talked about numbers get bigger to the right and smaller to the left. And when we were comparing positive numbers and negative numbers, we decided, oh, well, as long as I know where that number lies on the number line, the number farther to the right towards the positives is always the bigger number. And so if I'm looking for everything less than 3, I know 3 is not included. It's the last number that we can't include. Okay, but I know that 2 would be less than 3 if I put a 2 in there, or a 1 would be less than 3, or a 0 would be less than 3, or a -1.5 would be less than 3, or a -2.5 would be. So there's a whole bunch, infinitely many points anywhere down on this side. No matter where I put that point, if it's a fraction or a decimal or a whole number, it doesn't matter, because it is always going to be less than 3, and that's where these many solutions come from. Okay, we say that there's many solutions, and so to represent that, we actually just use a line. So we put an open dot where the first solution that doesn't work is, which is 3. 3 cannot be less than 3, but anything below it is less than 3. And so we have to be sure, there's a few things. We have to be sure that we put this arrow here, because these numbers do keep getting smaller and smaller forever, right? And that all of those numbers are also included, because they are also smaller than 3. On this other side, though, where I didn't put my line, you can see that a 4 would not be less than 3. A 5 would not be less than 3. And so what the line actually represents, this blue line here, actually represents where the solutions are. So we're looking to make a line where all the solutions are. When I talk about less than or equal to, then I can actually include the 5, because 5 is equal to 5. And now I'm thinking about this, okay, well, 6, would 6 make any sense? No, 6 is not less than 5 or equal to 5, and 7 is not less than or equal to 5. And so I know that 4 would be less than or equal to 5, 0 is, negative numbers are, and so to represent all of the different ways it can happen, even the decimals, even the fractions, anything smaller than 5, we use a line to represent that, and it encompasses all the solutions. Anything that I could put in for x, that would make this true. And so no matter what I pick, as long as it's on this green line, I know that that will be less than or equal to 5. And so the point of emphasis would be that this time we have a closed dot, because it's okay to be equal to. On the first one, we had an open dot because it was not okay to be equal to. Let's take a look at this next one here. And again, I'm going to try to find that number that's like the boundary number. Okay, and 4 in this case would be the number. It can't be equal to 4. Okay, it's only allowed to be greater than 4. And so I know the greater values are on the right-hand side this time. 5 would be greater than 4. 6 would be greater than 4. 6.1 would be greater than 4. All the numbers to the right would be greater than 4. And so I know that x could be any of these numbers over here, and I want to make sure that I emphasize you need to put an arrow, because these numbers keep going forever. There's many solutions. It's never going to stop. And so I do want to also emphasize that it's not okay to be equal. 4 is not greater than 4, so we're going to make sure that we leave this as an open dot. Okay. Finally, we have a greater than or equal to, and I'm going to start at 6 here. I'm going to put a nice closed dot right there, and the reason I'm putting it closed is because it's okay for x to be 6. It's all right to be equal to. And now I just decide which side has the bigger numbers, because I would like any number I put in for x to make a true statement. If I try 4, 4 is not greater than or equal to 6. But if I try a number on the other side of the line, like say 8, 8 is greater than or equal to 6. In fact, anything on the right side is greater than or equal to 6. So I know my graph that represents my solutions, anything that x could be, will be an arrow pointing towards the right. That includes everything, even the things in between the numbers, counts as a solution. Okay, so I want to emphasize that because it's okay to be equal, we're going to put a closed dot, and I know that all the values to the right would make this value true. So that's it for today, guys. Graphing inequalities. I got one nice graph of each one on there for you, but you just got to really kind of think about, hey, okay, well, which side is it that we want to make the true statement? So that's it for today.